So now, first step is decompose the things. Decompose, I think, use about 5 minutes. We can do it. And the command, basically, when we do things, we are cannot allowed to, not allowed. But usually people don't like you do the things on the master node because everyone work there. If you crash the machine, everyone is in trouble. So you have to use, a computation node. But on the cloud, if you use the master node, you don't pay extra money because you paid already. But you use the computation node to pay it. Every time you use it, pay it. So today I just show you we can run it on the master node. This is the scripts allow you to run this process on the computation node. You are familiar with this one, srun that we did. Here at the n equal 1, basically node, I want one node, I want one core, like this. So we don't need to do this, we just...
No, wait. One node, I'm sorry, srun is going to run for one node.
Don't worry about now. Later on, there are going to say better things than this one. It's much better, clearer than this one, because when you run the model, you have to have, multiple nodes, multiple CPU. So I will show you that exactly, the same first. So the next step. So basically, how it does. This is a program we just compiled. I think we call it differently. We call it one CPU, right?
30.
Huh?
32?
No, oh yeah, you are. Thank you. I think we call it days. This is preparation, decomposition, and this tells the computer how many CPU you want. I want 32. Finger crossed, let's see. Now because I think probably there's something wrong here.
I think just call it 32 without CPU, I forgot.
Yeah, oh yeah, we just go give a look. Give a look, it's here, it's not far away.
Yeah, you just call it 32.
Oh, 32, yeah, that's a good memory. Okay, thank you. I see. Yeah, this is the decomposition. That decompose tell you what I'm doing, This decompose kind of, the initial condition.
No time at all.
This parameter control files, lat. This kind of, the energy growth rate files. There's a lot of things, but it's working. And it takes a little bit of time because when decompose the forcing files, also the hydrodynamic files is huge.
So that takes some time.
Yeah, they did. But a couple of minutes, I think, be patient. I think, it's very
I gotcha. So this
go
takes
over.
a couple of minutes.
Probably 5 or 6, I think.
A batch file that ran this and then ran the program. You can write a batch file to run the prep and then run the program and then run the post-processing.
Yeah. Basically. Yeah. So, what it's doing, I just, what was this one? Yeah, this one I want, we remember things, and this usually I do is kind it's working or not. Where is it working? Yeah, this is a program we use, yeah. So it's still running, so that's good. Now, I think probably more than half has been done because this one done already. Oh, these are things. These are things that here I just try to just set up, to run 1 year. 10 year you would need 10 hydrodynamic forcing files. But 1 year, basically you need 1, right? but Carl told us that the code always look the next one before, prepare the future. So here I put a 2 in fact. So take another little bit of time to get. But potentially I can remove it. Yeah, I can remove it and use the same file 2 times. It's fun, right? It's fun. But theoretically, better to that one take a little bit longer time.
I missed that. So the preprocessor reads 2 years of data.
Yeah.
And then it starts the simulation program?
No, decompose it.
It decomposes all of the files first?
Yeah.
All of them?
Yeah, all of them.
So what were you talking about trying to remove?
1 year, you needed 2 years.
Remember the way it does the read ahead? Carl was talking about that, so that if you had at day 365, when it gets there, it tries to read 366. So you need that extra hydrodynamic file, even if it's not going to use it. That's what Richard was talking about. You have the 2 files. It has 2 hydrodynamic files, but if you want to recycle it, you can get rid of the second file that it's not really using. Cycle the one twice.
Yeah, like that.
Like
that. So you can see that this is basically Carl, talked about this morning. This we call the no point source files, no point source nutrient loading. You can see there are 2 years. In fact, we just use 1 year. Okay, 19.1, but I put 92 there, kind of for safety. If it's blow up, probably caused by that.
And so this is creating now 32 times 10 hydrodynamic influence.
Basically, yes. And before, you can see this is the same location, same folder. You can see we do LS, that's what I did. This is the decomposition result. Okay, this is for the kind of CPU number 27. Probably you remember I removed everything.
That's the core.
Yeah, the core number.
That it's going to run on.
Yeah, exactly.
You did an LS of PEO 27 and 28. They would have the same file names.
Exactly.
Okay.
But
different in.
Exactly. Yeah. Exactly. You got it.
Different directories.
Yeah, different. Yeah, they have each. We can see one, but it's not almost finished. But we just do one.
So
Let's see.
Putting all of that stuff in the different directories.
Yeah.
Okay.
All the input files.
Yep.
Some of them are just simply a copy, but some others really a portion of that.
And some of those files would actually be empty because if those nodes don't have that particular input in it, there's nothing there.
Excellent.
Okay.
I think we are almost there. No, it's done. So I think about 5 or 6 minutes. I think it's 6 minutes, but that's fine. Now we already looked at here. Look at this one, and this created. We can look another time. Now every 14 files are there. There's one copy, the same name as in this file, in this folder. Yeah. Now we can run it. The best time, best moment. So run is this one. You have to have a scheduler called. We use the Slurm. Basically, this script that run the model is here. What I said is that I want 1 node, but in fact 1 node has 36 CPU. I don't need that much, but I use 32, just 4 left. Okay, it's a waste of time or not, a waste of money or not, I don't know, but it's amazing that one time, I think all our nodes were used, but I still have 4 left in 1 node. Okay, 8 is 32. So I add another job, actually it's running. Yeah, that's amazing. It means that really you can use the 36. So basically,
Well,
it's
in a sense, just one, you'd probably want to save one CPU to be the master. I mean,
Yeah.
transfer.
Yeah.
So you
Yeah.
probably don't want to use all
Yeah.
36.
Yeah, like that, yeah. Because this also save you a little bit of memory because we are limited by memory. And the good thing is that when it's submitted, it sends you an email, call you, it started to run. When it's finished, I'm done. So you can, get the message. And here, basically, is how you run it. Do you remember? S run, and usually we put a 1, but now we put a 32, right? We use 32. Basically, this executable we just compiled.
What's the ampersand?
Run it in the background.
Oh, okay.
Yeah, so now we do it.
So quick question.
Yeah.
On your previous version, when you had the one CPU, you had the minus N, minus N1, but you also had minus task.
Yeah.
You don't have a minus task here. How?
No, I think it's not necessary to put that up, but at the beginning we kind of struggling to make it works.
I see.
So we test this, test that. Yeah. But finally you don't need that, like this to work. A good question. So
that was
Relatively
trial and error.
Yeah. So now we just run it. You have to submit this script. Submission command for Slam is you mentioned the name batch, right? But Slam batch is S batch. Okay, you use the batch in your PC, but S batch. Let's go.
A quick question. Again, just thinking of normal Unix, I would just say /run. So what does the S batch do rather than just say run ICM at CSH?
Yeah. Kind of require the resource already, right? You set up, I need first to get the node. And also, I think even on PC, when you do multiple jobs simultaneously, parallel basically a lot of jobs each have.
The S batch is tied to parallel.
Exactly.
The S batches.
I don't know. I've never used S batch. That's why I was asking.
And you just said now you understood. So I'm trying to understand.
Well, I think what it is if you're running apparently, just to make sure I understood it, if you're running multiple versions of parallelization, somehow you need to use S batch. Although I don't know what S batch does.
You want to make up? You have no? I thought you.
Sure. So S batch is a collection of jobs. So inside S batch you can have multiple job calls.
Multiple job calls?
Yeah.
Okay.
So what Richard is doing is he's submitting a batch job.
Right.
Inside he was showing that he had some module load commands.
Some what?
Commands for loading some of the modules.
Oh, okay.
Yeah.
And then he was running a job which required 32 CPUs. But at the same time he can also run several other jobs if necessary.
But could you just type run ICM CSH without the S batch command?
I think that should work.
Yeah.
It would. So the S batch is sort of like an upper level management.
Exactly.
scheme.
That creates a job and sends it to the scheduler. And now a scheduler schedules several jobs that are inside that batch job.
Oh, okay.
So
And if you run it without the S batch, you basically saturate your machine and you can't do anything else. But if you run it with the S batch, then you can submit other stuff? Is that what I understood you to say?
In both cases, it won't block your machine because you're submitting the job to the scheduler. But srun is one job instance, and batch is you combine multiple sruns within a batch job.
And we are combining multiple S runs because we're running, no, we're not. This
You're
is
only
just
running one.
Yep, so it's not necessary.
It's not necessary.
So to answer your question, we just do this. Let's see if it works or not.
Right.
Hopefully, I will not break the computer. Oh, sorry. What? No. So what I'm saying, just do the way we did the 30 box model.
Oh, so you're not going to let it go in the background?
Yeah, let's see.
Okay.
I think it's still background, huh? No, you know.
As long as you don't put the ampersand or the ampersand or whatever
Yeah,
you
yeah.
call it, it'll run.
How do you think I could
I think it won't work because you need to load those modules that you had in the script.
Yeah, that's true. That's true.
Go
Yeah.
ahead and try
Yeah. Yeah. Okay, we just do a try.
for the resources.
Probably it will be broken. So let's see if there are any. This is the way you look at, there's a problem is that it's waiting for Amazon to allocate the computational power that you are requiring.
Who's got the power?
Is Amazon. Is what's his name? Bezos, huh? What?
So now is it running? Because the message is different between the two. One says REQ, no, and
Yeah, yeah.
resources.
Queue is just, you just queue up. Resource means that it's looking
Still
for
out
resources,
there.
yeah, where I can find this 36, that's 34 for you, 32 for you. Still waiting, so that's
Just out of curiosity, one more favor. Could you type TOP and return?
yeah, sure.
Okay.
No, it's not there because
It's not there yet.
no, it's in the on the computation node. You don't see here. The here is a master node.
Okay.
Anyway, I think it's not basically maybe it's not a good idea to do this way. We just
Do it the other way.
Yeah, just stop it. Stop it.
So now you're running this model on
No,
the
you-
computation of
Yeah,
not master.
yeah.
Well, never
Yeah.
got into execution.
No, yeah.
The-
But it's still there. I have to remove it, right? Maybe we will have a better chance. I'm not sure. Okay, so basically the job we submitted is cancelled now. Just show you that. We use now we do the way we use to do this test for for Jim's suggestion. Basically, we do this. This is the wrong. Okay, it's the same way. So we made it on the job, but this immediately.
Immediately put it in the background. Okay.
So we can work here. I think it's just simple, maybe quicker. Yeah, still loading for waiting for the resource. Anyway.
And that's because, and it may wait for a while because you're trying to do the full 30, the full
Yeah,
year,
yeah,
the full run.
yeah.
And so there are a lot of resources.
Here, yeah.
When you're asking, when it's waiting for resources, is it waiting for the CPUs? Is it waiting for memory? It could be anything that's making it work.
Yeah, basically it's the CPU, the node
Right,
that,
the
yeah.
CPUs, okay.
How they do it exactly, probably John knows how, what happening now. But basically it's waiting for the resource. So anyway.
And do you know how many total nodes or CPUs are out on the system right now?
We have this up to you how much you set up, how many.
I'm sorry.
We set up 8 nodes. Each node has 36. So 36 multiplied by 8. That's a total computation
So
power.
when you say you have those 8, those really are your own, owned by you. You're not waiting for
No.
the rest of the...
No, we don't have it. That's the maximum you can ask.
Right.
Yeah.